you. All right. Ooh. Voice of God. I'm no Morgan Freeman, but I can get a little echo going at the right time. Welcome, everybody. Welcome to Alta Sea in the Port of Los Angeles. Are you happy to be here? All right, that's just to get your blood going. It turns out that there was a pop-up car show that, and some of you may have had to get through this, out in the street that blocked off the street, and the police are out there trying to move them away so that at least people who are trying to come here can get here. So unfortunately, we can't wait because we've got a live stream going on, and I think the live stream has started. Can we confirm with our tech in the back? Thank you very much for making sure we are heard and seen. So again, welcome to Alta Sea in the Port of Los Angeles. I'm Terry Tamminen, the President and CEO. The chair of our board of directors is here, Dr. Geraldine Natz. There she is. Great big round of applause for Geraldine. And you are all dignitaries, but there may be some other political appointees or elected officials or other dignitaries who come in during the day that we may recognize, but we thank you all for being here. I want to just, first of all, remind you that the activities today are not just here. You're going to hear a great talk by Dr. Tony Michaels, and then you're welcome to wander around and see the amazing Kelp Lab next door, Holdfast, which is an amazing facility that is growing oysters and clams and other seafood. You can learn how that's done. And then outside, if you go down about 100 yards, you're going to see the Ocean Research Barge, or the Orb as we call it. And there's an underwater robot there that you can have some fun with and see what's going on underneath the waves. Our education manager is there. We'll tell you all about our education programs and so forth, so please enjoy. And I would be remiss if I didn't explain the cap that I'm wearing. This is our Resiliency Program, because we know that with climate change and with all the other threats to our environment, we have to become more resilient. So this is a campaign that Alta Sea has launched to be able to put funding and support into our education programs and to help the next generation do better than my generation did. And so if you feel like supporting it, please become a member of Resiliency. And you can see right back here at our table, there's Natasha. Natasha, wave. All right, Natasha's busy recruiting another Resiliency member, but you can get this great swag. You can join, become a member, grab one of the tote bags or anything like that and support a great cause. And thank you to those of you who have already done so. All right, well, now it's my great pleasure to introduce Tina Calderon. And Tina, where are you? Tina, there's Tina. Tina is our culture bearer from the local Tongva, Gabrielino, and Chumash nations, and we'd like her to offer a few words of welcome and blessing.
Thank you, Terry. Tehobet Tamet Nehinkam, good morning, relatives. Netwanyane Tinor Duno Calderon, Komikrabet Neha Tongve, Koi Mixkanakan, Koi Yoeme, Awesh Koneha Aqua Avomane, Tehobet Tamet. I am Tino Arduino Calderon, Gabrielino Tongva, Ventureño Chumash, and Yoeme, and I'm very happy to be here with all of you today. It's a beautiful day, isn't it? I like the overcast. And I understand that we might be getting a little rain coming into certain parts, so let's pray for that. We need it. I want to start by acknowledging my tribal relatives, past, present, and emerging. They're the original Tarahatam, or peoples of Tovangad. And Tovangad is our world, it's our territory, which ran from San Fernando Valley, south to Newport Beach, east along the Santa Ana River to Corona and Riverside, and back along the foothills. So we actually had a very large territory. We also held the 4 Southern Channel Islands. So with that, I also want to acknowledge the peoples of the village that was here locally, Chalvengna. So we thank those caretakers that were here for millennia, Chalvetam, Awish Koneha. And I'm gonna go ahead and offer an ancestor song. I'm going to put this down so I can use the clap stick, and I think you'll hear me. I think they'll hear me, though.
Okay, all right.
I'm pretty loud. So that's an ancestor song. It says good morning to the ancestors, and it calls to the four directions. So in that way, I call to all of your ancestors. They are here with us. We remember the ancestors. We thank our elders and our teachers. We stand with our children and the 7 generations to come. Thank you so much for the inclusion. Have a wonderful day, and I'm excited to learn along with you.
Thank you, Tina. Thank you so much. We are reminded that this area has been occupied by humans and other living creatures for centuries, long before this port was here. So thank you for reminding us of that and calling on the ancestors. Before I bring up our amazing guest speaker, I want to recognize the team that brought this event to you today and that has done all the work here at Alta Sea, starting with our founding executive director, Jenny Crusoe, who's right over there. Many of you know her for her many, many years of work here and in San Pedro. And our entire team who are wearing blue t-shirts like this. There's Natasha and Carl in the back. Robin is here somewhere. There's Robin and Walter standing over there. They really did a lot of the setup and the hard work. Charmian and Angie are there. Carl, I think, is right back there. So the whole team is here today. And if you see anybody in a blue t-shirt, please ask them more about Alta Sea and how you can get involved. This place is going to be transformed over the course of the next few months. We already have a brand new roof on the 180,000 square feet of the warehouses here. Solar, 2.2 megawatts of solar is going to be installed in the next couple of months, enough to power 700 homes. So we'll be exporting clean energy much more than we're using. And these warehouses will start to be renovated into a modern research and development campus so that some of the things you can see already happening here, like the Kelp Lab I mentioned, will have nice modern facilities to operate in, and many more researchers coming, including the ones that Dr. Michaels is bringing here to the campus. So there's so much I could say about Tony, and he's hoping I don't, but I've known him for many, many years. He's a very dear friend, and I've learned so much from him. We have traveled the world together. We've been in the Middle East together in the blazing sun. We've been in the mountains of Europe, and we've been in Africa. We've been in Central America. I mean, everywhere, looking at aquaculture, looking at various other sustainability and climate solutions. He was the original director of the Wrigley Institute out on Catalina Island for the University of Southern California, and has had an amazing career both in academia, but then one of the reasons I love Tony is because he applies that learning and that knowledge to modern aquaculture, agriculture, sustainability solutions of all kinds. It doesn't just stay in the lab, and that's what's great. And he can explain anything. He can make any complex subject seem simple to idiots like me who didn't pay attention in my high school science class. So with that, let me welcome the amazing Dr. Tony Michaels.
Thank you. I got to live up to that. That's no fair. Hi there. Thank you very much. Thanks for supporting AltaSea and for listening to me talk a bit. You know, there's a little bit of danger here because I was a professor for a number of years, and that means when I'm asked to talk, it's 60 minutes and a test. And that isn't what I think you have signed up for today. But lately, I've been doing a lot of large-scale organic farming, and the one thing I still have never caught on is this man of few words kind of thing that they talk about with these farmers. So you're going to get a lot of words. They're going to come quick, but I'm going to try and keep this relatively short. So I'm going to talk about aquaculture and the future of aquaculture, especially as it relates to what we're doing here today. And I don't know how well you can see. Hopefully you can see these slides, but I'm mostly going to say the things that I want to talk about. So I'll talk a little bit about what aquaculture is, the future of aquaculture, sort of the big issues that I think are laying out there, and then what specifically the companies and university partners at AltaSea are doing in these areas right now, and the kinds of things that we're going to build on from there, and then finish up with just a few words about why you should care. So a lot of this will be about kelp and algae. A lot of this will be about other forms of animals that we eat from the ocean. How many of you ate kelp this week? Seaweed. Okay, so we got some people that have probably had sushi, right? Right. How many of you, I don't know, brushed your teeth this week? Hopefully all the hands go up. Any of you eat cheese this week? How about ice cream? That's not a lot of ice cream people. If this is Wisconsin, all those hands would go up. You ate algae. All those products have algae. Algae aren't just the leafy things that we think of as part of sushi or vegetables. Algae make a lot of interesting products, and thickeners are the biggest one. Carrageenan and these other chemical thickeners that make things like ice cream hold together. And they're good for you, and they're all natural. And so you actually eat a lot of algae, and we'll talk about that some more as part of I go through this. So what is aquaculture? Aquaculture, it's just growing stuff that lives in the water. And it doesn't matter if the water is fresh or if it's salty or if it's somewhere in between. This is about the industry of growing something in water for a purpose, farming. Okay, so it isn't just your pond that gets all green and scummed over your swimming pool. That's not aquaculture. That's growing something in water by a mistake. We're talking about doing it on purpose for a need or a value that we have, and those values are things like food and energy and these thickeners, chemicals, pigments, even creating environmental benefits and more. So it's growing the things that naturally live in the water for a purpose of our own. And so when you think about agriculture, or aquaculture, it's going to think, what are you guys going to know about aquaculture? Well, if you saw the topic, you might have Googled it. So I said, let's go Google the future of aquaculture. What do you see? What you see are a bunch of pictures that look like this. This is the first few pages of images that come up. These are fish pens. Okay, big circular ones that are submerged, or net pens that are sitting out there in estuaries, or sometimes big tanks with water treatment things all around it. When we think of aquaculture, we usually think about fish. We think about people talking about farmed salmon and whether that's good or that's bad. Because aquaculture, put in the coastal zone, makes some very interesting, healthy fish for us, but it also has some problems associated with it. And those problems are things like pollution. You dump a lot of food in there and it doesn't all get eaten, and the next thing you know, you've got nutrient buildup. Some of them get out and they escape into the native area. Sometimes you spread diseases. We feed them the same kinds of things we feed chickens, and so flesh becomes more like chicken and less like fish, where fish is so healthy for you when it's got all those good omega-3s and stuff in it. And FIFO is this acronym for the fact that a lot of fish that we want to eat, like salmon, are actually carnivores. It's like eating lions, not cows. Because these are fish that ate other fish, that had eaten other crustaceans, that had eaten other little microalgae, microplankton, that had eaten the algae, right? It's a very high trophic level kind of a thing. And so we are harvesting way more fish out of the ocean to feed fish, to get a little bit of fish for us to eat, okay? And these are kind of the problems, and if you talk in the United States about the future needs of aquaculture, it's thinking about fish and solving a pollution problem, okay? Well, first of all, most of the fish that we grow in aquaculture are not ocean fish. They're mostly carps. The top 6 fish that we eat are carps. And then you have in that list a little bit further down, you got catfish and you got tilapia, freshwater fish. And freshwater fish are grown mostly, this is in Asia, most of aquaculture is in Asia, and it's a fairly low intensity kind of thing. You put a pond, you fill it with fresh water, you put some fish in there, you feed the fish grow, and you haul the fish out. This is a very common source of protein. And so when we think about, and the other thing we think about with this is we're always comparing the aquaculture fish with the fish that you grow, we catch wild, right? We're still hunter-gatherers in the sea. We go out there and hunt and gather with our boats, and we catch fish and bring them back. But this is a figure from 1980 to the present. The blue is the wild capture of fish. And you can see, at kind of about 1980, it leveled off, and we can't get any more fish out of the sea. But we still get lots more people, and we could be a lot healthier if we ate more fish. The green is the growth in aquaculture. And we always think about that. Now we're getting half of our seafood from farmed and half from wild capture. It's not really true. Most of the fish we're catching is this freshwater fish. We're still farming very little ocean fish. And what's totally missing is the algae, the plants. So if you look at a global picture of what we actually farm from the sea, freshwater fish, the blue here, is 40%. Aquatic plants, mostly marine, but some freshwater, are almost 30%. 70% of this is freshwater fish and algae that aren't in any of the things that you're Googling when you're thinking about aquaculture online. Okay, this is the real world of things that are easy to eat, they're low on the trophic thing, they're either plants or things that eat plants, and so they're very efficient in terms of getting us fish. We got 8% of what we grow is marine fish, tiny, tiny percentage. And remember, this is half. This is the number that we're comparing with the global wild caught. A little bit of marine crustaceans, that's shrimp. And now it's pretty much one species of shrimp is about 7% of that. And then farm mollusks are about 16%. This is your mussels, your clams, your oysters, all the little filter feeding things. And so this is what aquaculture really looks like. So if you're going to spend your time and your energy and money getting more food and better food for people, do you put it all here, or do you put it all here? This is where the real opportunity to cultivate food for ourselves is in the algae and the freshwater fish, and the ways, and the farm mussels, the things that go along with it. And that's what I'm going to talk about here. That's where we're doing something that's different, and it's different in some very important ways. I'll make a distinction between what's called extractive, horrible word. These aquaculture scientists need more marketing help. Extractive aquaculture versus fed aquaculture, okay? Extractive are things that when you grow them, you're really growing them on nature's services. They're growing on the nutrients that are in the water, they're growing on the particles, the fine little plankton that are in the water that they filter out. They're taking those nutrients into their bodies, and then we're hauling their bodies out of the water. Versus fed, where you bring these things in, you put them in there, and you start throwing feed at them, where we're adding nutrients like crazy, and these are the fish and the crustaceans. So that's a dichotomy, extractive versus fed. When you look at that dichotomy, the thing about extractive is they're taking nutrients out of the water, some of them they're putting back, but there's kind of a natural cycle that they're participating in a way that then we haul something out that's valuable to us. When they're fed, there's no choice. You put some fish in, you bring some food in from somewhere else and feed those fish. And then you take out fish that's a lot less material than you put in for feed, and so what's left over is pollution. And so that's always been the dichotomy in this process. But notice these are sort of complements of each other. One's taking nutrients out and cleaning the water, one's making the water dirtier. Okay, we'll come back to that. The other key thing, and this is my farmer hat on, I wish I should have a farmer hat, is that if you pollute fresh water with nutrients, I call it fertilizer. If you pollute seawater with nutrients, I can't stick that on a field and grow a crop with it. And so that pollution has to be cleaned up and managed explicitly. Whereas if you do this right and you put the pollution, it's just nutrients, into the water that's fresh water, I can put that on a field and I can grow the crop that was the feed in the first place, okay? So there's every place. You've got to be looking for where these are complementary or where they're cycling. So this is a little bit too small of a slide, but there's a thing called Multi-Trophic Aquaculture. Good name. They actually even have initials for it and it bandy it about like an acronym. But the idea is that you got something like fish, okay? So this bucket's fish. And these are the ones we're feeding. So we grow some soybeans and some corn somewhere. We throw in a little bit of fish meal and a few other the nutrients that fish really, really need. Pellet it up, and we stick it in the fish. And those fish eat it. Some of it they miss and it rots. And then they poop and they pee. And I'm sorry to use these highly technical terms on you, but you know, they poop and they pee. That's just nutrients going back into solution. And one organism's food, waste is another organism's food. So the particles that they don't eat or that are waste, filter feeders like the mollusks, the clams, the mussels, they eat those and grow on them. Both of these, the fish and the mussels, make dissolved nutrients, ammonia, phosphorus, things like that, that are the food for the algae. The algae have this trick that they can use sunlight to get their energy. They don't have to get it from their food, and so they use that sunlight. They make their bodies by using those other nutrients, and they're cleaning up the water. And so you can see how these are complementary. Maybe someday we can even take some of the mussels and the algae and make the fish food in the first place and completely close the cycle. But the sun comes to this, the energy comes through the sunlight into the algae. Algae also make oxygen. The animals use oxygen. All these nice balances. People have thought about just doing this structurally. You can say, figure out this thing is designed, pretend there's flow this way. If you had a flow, you have the fish first, you fed those, and then you have the mussels second. They take the particles out of the water. You have the algae next, and they take the rest of the nutrients out. And if you grow the right amount of each one of those things, the net is no net negative effect on the system. But more importantly, if you're a business person, you went from one product that you make money on, fish, and 2 waste streams that cost you money, to 3 things that make you money. And that's how we're going to finally get the cost effectiveness of aquaculture to the point where it becomes readily spreadable so that we can have this expand to feed more people. Or you can skip the fish. Because we got a lot of places downstreams of rivers. You know, the Mississippi's loaded with the extra fertilizers from all those fields flowing out into the Gulf of Mexico. We have all of these places where cities and other things dump nutrients into the water, and that's a pollution problem that eutrophies the system, makes the things that normally would live there have trouble. Want to fix that ecosystem? How do you get the nutrients out? You can either stop the city or the farmers, or you can put in the same kind of extractive aquaculture, get those things out, and give the ecosystem a chance to recover. Now this is also being done industrially, and this is, I think, is the exciting thing. I lived in Wisconsin for much of the last, or about 6-year period before the pandemic, and this was a company that just showed up out of the blue down the road from us. This is just north of Madison, Wisconsin, and this is a fish farming company. It's called Superior Fresh. They grow salmon in tanks. Salmon go go back and forth between the ocean and the rivers, so they can grow on fresh water. So they use fresh water to grow salmon. They feed the salmon from things that they harvest on their farm. Makes pollution in the water, which is nutrients. Those nutrients are then under this. This is a bed of water with floating lettuces and leafy greens growing on top of it. Look at the size. There's a person on the very far end of this. Look at the size of that greenhouse, all being fed by the nutrient-rich water that comes from the fish farm until that water's clean, and then they put it back in the fish. They get year-round salmon, year-round leafy greens. You go into the grocery store, you see Superior Fresh in the produce section and Superior Fresh in the meat counter for the fish case. It's a neat, high-tech way of doing it. This is the kind of stuff we ought to be really good at, and I think that's important. Because when you think about what is going to really drive agriculture, aquaculture, you got to follow the money. If someone's not going to make a living doing this, they're not going to do it. We have to have aquaculture be something that's financially profitable to the farmer that's doing it, and not create a whole bunch of problems that either the farmer or somebody else has to solve. And I think we also have to do this in the United States. 90% of all the stuff I've talked about so far is in Asia. Asia's really done this in a big way. You know, these grounds that we're on, people have been eating these things out of the ocean and even doing low-level cultivation for millennia. We can do these things very easily. If we're going to expand this, we have to be able to do this in the United States. And that means doing a version of those technologies that works really well for us. We got to build out those extractive technologies and these polyculture kind of approaches, and we got to get rid of these problems with the Fed Aquaculture. So what is AltaSea doing? AltaSea has a whole series of partners that are here, some of which you can see today, that are actually making a choice for where to invest their time and their money in the future of aquaculture. What are they picking? They're picking the kinds of things that I talked about as the big gaps. So the first of these is the Newton Kelp Lab, which right on the other side of that wall, that's the first chunk of tanks that you come to. Faculty member at USC. He's a genetics guy doing plant genetics and whole genome sequencing and all that sort of fancy stuff that universities love to get money to do, but he likes kelp. So he says, I can do Arabidopsis, but I can also do kelp. And so he's been doing sort of the modern genetics of plants on kelp. And the kelp he's using is the big Macrocystis kelp that we have all up and along our coast. Fastest growing plant in the world. If you got to pick one, let's do that. And he's using that genomics to say it took 10,000 years to domesticate cows and pigs and goats and chickens. We don't have 10,000 years to work on this planet. Let's use the real understanding we have now to speed up this process by understanding what genes are there and what those genes can do. And do that in ways that also solve problems. Let's get rid of this invasive species problem where these things, if they escape, then destroy the rest of the ecosystem by flooding it. Let's think about, we have a gut full of microbes that really influences what we do for a living. These algae are loaded with their own microbiomes. A lot of the behavior of algae is because of the bacteria that live inside and alongside them. You got to understand that if you want a farm product that's going to do what you expect it to do when you put it into a farm. We've got to improve how they grow, how much nutrients are in them, their effect on greenhouse gases. We've got to create industries that make seeds available. When we farm in the Midwest, we don't grow our own seed. We buy the seed that's exactly the right seed for that farm in the year that we're anticipating is upcoming. But at the same time, we love our oceans, and we've got to support doing this in a way that then also helps the conservation of the sea. So that research group in the university has spun off an entity, not sure if it's for-profit or not-profit yet, but it's the first true algae seed company. AltaSeeds is the name. You know, clever. I mean, maybe they're getting a little bit of marketing expertise here as scientists. But this is, again, Sergey Newton. It's a spin-off of the lab, and it's a seed company. I can't go through it because I can talk forever, but there's a trick with the weird life cycle of algae, that there's a spot you can just sort of turn off, and when you do it, you have the ability to have sporeless kelp, the same way we have seedless watermelons. Okay, how do they grow seedless watermelons? Where do the seeds come from? Well, you know, they figured that out, right? He's done the same thing for kelp. How do you grow a sporeless kelp so it can't just reproduce on its own and then flood the ecosystem next to the farm with all kinds of kelp where kelp wouldn't normally be? And so that innovation is extraordinary. It lets these plants really be defined by the thing you want to grow there. And the trick with it is, in that trick, you can then have all these pairs, these parents, that you cross into something which itself can't reproduce, but is the exact right traits for the place you're trying to farm it. So they know what the traits are, they can have libraries of those, they can put the right combination together. I got a farm, it's here, I got a farm, it's in Massachusetts, I got a farm, it's in the middle of the ocean. It needs kelp that do a certain thing. I'm going to give you a seed that does that certain thing. Now another company that's also just on the other side of that wall is Holdfast Aquaculture. And Holdfast Aquaculture is doing a similar kind of a thing, but it's doing it for animals. And what their trick is they're going to build one of these intensive indoor things where they're going to have the water, they're going to clean the water, it's all going to be indoors. But to spend the money on that, you got to grow something that's worth something. And what's worth a lot? Seeds are worth a lot. So they're revolutionizing the way we think about the babies that you have to produce for things like mussels and clams and oysters and these bivalves. Again, extractive species. There's a lot of neat genetics that's been going on where we can get these things to be more adapted to being farmed animals, that we can get them to be more adaptive at doing environmental cleanup and those kinds of things. but then someone's got to grow those so you can order up a batch that's good for where I live and the farm that I have, or one that's next to a set of algae or a fish pond or something like that. And so they are now doing mussels. They are commercially available. They're selling mussel seeds. They're selling oyster seeds. They're working on clam seeds. And they're also doing some stuff with the microalgae on how you do the propagation side of the genetics that's being done. So again, the extractive piece, the piece that solves the problems as an integrative system. Now there's another company whose stuff is on the far end of this, and I don't think it's open today, but Pacific Six is an investment group that's been investing in next generation aquaculture, and they have two projects that are relevant and done in partnership with Altasea. One's Pacific Mariculture, and Pacific Mariculture is doing the next hard thing, because we love the ocean. We don't kind of like to look at stuff floating on the ocean. We don't like those oil rigs out there. We don't like to see fish ponds right next to our ocean. So there's a use conflict issue every time you do something near the coast. Still, it's a lot easier to do something near the coast than drive a boat into the middle of the ocean. But ultimately, 70% of the planet's ocean. And if we're going to feed the planet with more stuff that's low impact, clean ways to provide food in water, it's going to be because we use the open ocean. They have the first open ocean lease from the federal government in federal waters, not state waters, to grow aquaculture species in the open ocean. 100 acres offshore of Los Angeles. And what they're going to do is take those seeds, put them on ropes, put those ropes out in the open ocean. The things grow up, the mussels and the algae. They go back out with the boat, haul those on board, strip them off the rope, reseed the rope, put it back in. And you've got an ability to go out there and actually execute on the farming side of this. So now we're looking seed to farm, harvest, and sale. They have another project which is also illustrative of what needs to happen. It's called Symbrosia. Now this is a microalgae product, but microalgae are kind of like little chemical engineers. They can make all these really interesting chemicals, and they're harder to grow. There's a whole bunch of other stuff that goes along with this, but the key point is you gotta be able to finally turn what you grew into a product. And that product, in some cases, is the kelp you ate, but in other cases, it's a chemical that you extract. It's a vitamin. It's the omega-3s that are the thing that makes the seafood healthy. They come from algae. And so when you're going to use these, they have to become ingredients so that companies that make food that we eat are out there doing that. And the sixth company, the last one, is one that was incubated here called Spira. They use spirulina, which is a blue-green algae. It's technically a bacteria, but it grows like an algae. It was incubated in Braid Theory, which is the early stage incubator that's part of Altasea. And Spira basically says, okay, if we're going to do this, let's get really focused. Because one of the things that we like to do is have pretty colors in our food. But pigments, synthetic pigments can be really challenging. Red dye #2, I mean, there's all these stories about why pigments aren't a good thing. Well, plants have colors. There's red algae, there's brown algae, there's blue-green cyanobacteria. Can you make colors out of that? So they extract, they grow the algae, they process it like almost a refinery, and then they create these powdered pigments. And this is a blue pigment is their first one. Blue's the hardest color that you're going to make a pigment. Well, I shouldn't say that. Purple's probably harder, but blue's a really tough one. And a lot of the blue synthetic pigments are really nasty kinds of things that aren't allowed in food. This is just an extract from an algae. It's beautifully safe, natural kind of a thing that you can then get these nice, beautiful, vibrant colors into your food. So that's a suite full of things that are going on here. And there's other companies like that. There's other research labs that are coming in to try and build on this, especially as Terry gets these all renovated and the space available, and we can bring both the university researchers and the companies in. But you can see we're picking the place where the opportunity to change the planet the most is the largest. So why should you care? Part of this is this food is good for us. It's good for us because it's got good nutrition, especially when it's grown right or we pick the right varieties. And when it's good for us because it makes us healthier. It's got a lot of good protein, a lot of good micronutrients, a lot of good energy, and hardly any carbohydrates that give us a metabolic syndrome and all these other things. This is good. We should eat more seafood. We should eat more of this across the board, except for a few exceptions for pregnant women. This is also something, because we've got so much planet, this is a very open niche. We aren't going to put a lot more soybeans on this planet. we are not going to catch any more wild fish. But we got a lot of ocean and a lot of fresh water that, done right, we could grow a lot more food on. So this is a place where we can get more food to feed a growing population in a way that's better for the rivers, the oceans, the lakes, the ecosystems around us. And it's also better for climate, because a lot of the stuff, 15% of all the greenhouse gases come from agriculture. And a lot of that's from very few specific things that we eat. And if we can eat more seafood, which is very low carbon or even negative carbon, we can displace the greenhouse gases that come from the food supply that we eat. But the real thing is it's got to taste good. Okay, the competition for kelp is not fish oil. The competition for kelp is In-N-Out Burger. You know, we want to have, this is going to work because it tastes good, because we want to eat it. And this, I think, is the thing that's really the big last hurdle. I'm working with a group of chefs on these kinds of things. How do you make things taste so good that you want them, you crave them? These are really good nutrition, they're really good for us, we can make them good for the planet, but we have to make them taste good. Chefs did an incredible thing for the conservation of swordfish and everything else by using their messaging power through looking at menus and influencing what we do. Can we get the food industry, who is driven by your desire to buy stuff because you like it, to take on these ingredients, make the food more healthful by using these things in the food we eat? So that's all I have for today. Thank you. See, I'm not a person of few words. I thank you again for your support of AltaSea. I'm happy to answer some questions. And yeah, so he says I've got 5 minutes to answer some questions, and then make sure you get out there and see the different algae operations in the next room. So any questions? Thoughts, questions? Are we going to put us back on schedule? Oh, pardon? Well, duckweed is a freshwater plant, and duckweed has some really nice characteristics. I can talk a lot about duckweed, but duckweed is this weird little lemna, I think is what it's called. It's like a couple of leaves and a root, and it floats on the surface of the water. So when you see a pond scum and it's brilliantly green, it's usually a duckweed kind of a surface thing. The trick with duckweed is it's so easy to get out of the water. Little microalgae, it's so hard to separate them from the water. You know, fish, you just haul them out. Mussels, you just haul them out. Big kelp, you just haul it out. Duckweed is right there at that interface where it's big enough and it floats at the surface. It's easy to harvest. And so now the question is, what are the things you can grow? It's a good protein source. It's got some other nice characteristics. So it's on that extractive side. It's a neat fish. A neat fish. Algae is a name is a more technical name for things that are all seaweeds. All seaweeds are algae. Okay. Some things that we wouldn't call seaweeds are also algae. Algae is the generic term. You know, we're all animals, but some of us are humans, and so it's that kind of a distinction. Yeah. Well, that's a good. She asked if. She was asking if there are poisonous algae. I don't know that question. I don't think so. So when I took my first algae class a few years ago, let's just say, you can see the color of my hair, we would take field trips to different places. And one of the things we always did is harvest as we went, where we would just, and we would have an evening dinner every night with the algae that we had harvested. And I don't ever remember anybody telling me that there was an algae that we couldn't eat. I do remember one time we had, on a field trip down in Mexico, we were all going through looking at these things, and it's a class, right? So it's like a game of telephone where the professor picks it up, explains what it is to the first little group, and then they explain it to the next little group, and it's kind of a line of students sort of walking across the intertidal. And all of a sudden we see this confusion at the far end, because the last group were a couple of big Samoan guys, and everything that came along was like, and they had to go to the end of the line because they were going to eat it before it went through. Much of what's there is, I can't say for sure. I think there probably is something that is harmful, but most of it doesn't hurt you. A lot of it doesn't taste very good. They concentrate things like iodine and stuff like that as just part, because there's iodine in the sea. And so there's things that just don't taste as good, or they're an acquired taste, like, eating kelp. You can just buy a little package of the kelp and toss it on a salad. Some people love it, some people don't. But I don't think that there's I can't think of anything that's poisonous. On their website, I think there's, I cut out the price when I scanned the thing, but yeah, you can just buy it right off their website. Yeah. So AltaSea has a master lease with the Port of Los Angeles. I should let Terry say this. We'll see if I get it right. Has a master lease with the Port of Los Angeles for about 300,000 square feet here and the open space on the other side, with a commitment that AltaSea is going to develop that for a variety of ocean-related uses. And so when people come in, they're effectively tenants of the space, but they're tenant partners. And so people come in, they have a use. They essentially work with AltaSea to find the space that fits their needs, the things that they're, and then they pay a lease for it as part of that. They do a lot of education and outreach because the port has asked AltaSea to produce workforce development and education, public outreach kinds of things. So AltaSea does those, but all of the tenants are also required as part of their lease to participate in that. So AltaSea has sort of a coordination role across all the public outreach parts of what's going on. But most of the people here are effectively tenants. No, you can be, the sky's the limit on creativity in terms of how you get involved. It's just got to be good for everybody, you know, and so there's sort of a higher public good standard that things are held for, but you can be partners with anybody, you can do it by yourself. We're not sealing anybody off. Everybody has to have some ability to express themselves to the public, so you can't just be a top secret think tank kind of thing and close the doors. Last question, yep.
DDT that's thrown out in our coast here, does it affect our environment or ways to make a farm here?
So the DDT that was, so the main factory, one of the main factories for DDT was in Torrance, and for years legally dumped a lot of DDT off in the outfalls. And so there's a big bunch of DDT built up on the Palos Verdes Peninsula. It gets into food chains. So there's fish like the white croaker and stuff that you shouldn't eat because the DDT has been concentrated up the food chain. Most other places, DDT doesn't intersect with the food chain and slowly getting buried and slowly breaking down. But it's still a problem. It's still something that's there and kind of capped, but not unavailable. The kinds of things we're talking about probably would never build up DDT, but it's the kind of thing, I mean, I would worry about PCBs. When you're out next to a city, you've got to worry about a lot of things in the water beyond just the nutrients. And so those are the kinds of technical and analytical things that you have as a fish farmer. Just like, I don't want to have E. coli in the lettuce that I grow in the Salinas Valley. I don't want to have, weird chemicals in the things that I grow in the Midwest. And so it's part of the parcel, but you do have to worry about that. DDT is very specific in where it's showing up now, and it's probably not going to be in these kinds of fish farms. Yeah.
Terrific. Thank you, Tony. A great big round of applause. Always learn something from this guy. All right, listen, we want to encourage you to go back and see the various displays in the back, including our artist in residence, Taylor. Where's Taylor? Right over there in the corner. Taylor will help you make a lure out of found fishing gear, I think it is. But anyway, go back and do an art project with him. Enjoy some of the other amazing artwork here and so forth. And again, please become a member of Resiliency that supports our education programs and all the work we're doing here. And anyone who's in one of the blue shirts, I think I failed to mention Dorothy before, who's been very instrumental in getting this thing put together. There's Jenny, there's Robin, Carl and Natasha back here, Walter, everybody is here to answer your questions and to help you become a part of AltaSea. Thank you for being here. Enjoy the rest of the day.